Hello, my name is Mark Black. In this video, we're going to look at how to prepare to install IBM Spectrum LSF Suite 10.2. This is part of a series of videos, so there are multiple topics that you can look at, and you can take a look and see which ones are of interest. So in this video, I'm providing an overview of the installation process. So I need to talk a little bit about the servers that are part of the LSF Suite cluster and the roles that those servers can take on. There are actually a number of different roles, and I'll just give you a quick overview here. The roles are really controlling what functions are being provided by each machine in the cluster. We have the LSF master role, and this role runs all of the processes necessary to manage the workload on the cluster. The LSF servers is a subset of the LSF master role, and these machines are responsible for running the actual work. The LSF clients are, again, a subset of the LSF servers role, and these ones can't actually run work, but you can use them to submit jobs to the cluster. The GUI hosts run the GUI for the users to interact with. The database host will host the database. And finally, the deployer is the machine where your installation repository, so the RPMs, for example, and the Ansible playbooks, this is where they all live. So let's look at a very, very simple cluster where we have, say, just a single machine. So what roles do we need to get on there to make this machine work? Well, we need the deployer. So the deployer is the piece that's going to install all of the other parts, so install all of the other roles. You'll need the LSF master. So the LSF master is, of course, going to run the services necessary to manage the workload on the cluster. The GUI host is going to run the GUI service so that you can interact with it, and the database is, of course, going to provide the database. So with this, what can you do? You'll be able to test out LSF Suite. You'll be able to see the application console, the process manager, and you'll be able to try out the MPI stack. It's really not intended for production. It's just a little bit too small, but it does allow you to try out LSF Suite and see what it's like. This is a more realistic cluster, so this is good for a small cluster, say if less than 100 machines. Of course, you have your 1 to 100 LSF servers, so these are where your work's going to actually run. And we have two machines that we've designated as LSF master, so they're running the LSF master processes. And we've split the other roles between these two boxes. So on one of them, I've left the deployer, so the deployer piece is here. And on the other, I've stuck the GUI host role and the database host role. So if I were to lose, say, this master box here, well, my jobs are still going to run because we'll fail over to the secondary LSF master. But in this configuration, I only have one host running the GUI host. So if I were to, say, lose this host here, okay, I've lost my GUI, but the jobs keep on running. So this is a small cluster of maybe less than 100 machines. Oh, another point, for the masters and GUIs, they do require a shared directory if you want to have, say, any type of HA. And that can be either NFS or Spectrum Scale. So this is a more reasonable configuration of, say, 100 to 1,000 machines. So we have, again, up to 1,000 servers. We've pulled the database host out into a separate machine, and on the separate machine we may want to configure that with say RAID array and maybe redundant power supplies, just to make this machine a little bit more reliable so we don't lose the database. Also, what we've done is we've spread now the GUI host role. We're now running that on the 3 boxes along with the LSF masters role. So this allows us to put a load balancer in front of these and load balance across it so that you have high availability access to the GUI for submitting work. One thing that you might want to do is, if you are fronting this with a load balancer, the primary LSF master, you might want to have that at lower weight just to take a little bit of the load off. Okay, so here's an even larger cluster. And here, again, what do? We start to pull the service out and separate them as much as possible. So you might even have an external database, set up for EHA. And of course, we've pulled now instead of running the LSF master and GUI host together, we've pulled them now apart. So uh, we've separated the load even more. So this will allow us to scale to, well over, to several thousand servers. Okay, let's talk about the machine prerequisites. So in terms of disk, we have two install options. You can install locally, and that will install in opt IBM, or you can install on a shared directory, right? So it could be either NFS or Spectrum Scale. One note there, we do install some components locally anyway, even though you have provided a shared file system. And this is really for performance reasons and for well, to make sure that the monitoring data is still available, even if there's a problem. In terms of space that you're going to need, for the LSF master role, you're going to need about 2 gigabytes. For an LSF server role, again, this is a subset of the LSF master role, so you're going to need about 1.5 gigabytes. For the LSF clients, 300 megabytes. For the GUI hosts, they're going to need about 32 gigabytes. And it's not necessarily to install, it's part of the pre-installation check. It's going to see if it has enough space for essentially for Elasticsearch and its shards. For the database, you're going to need a minimum of 150 megabytes, but that's going to grow. For large clusters, we would recommend using SSDs for the database and for the Elasticsearch shards, and they're found in varlib MySQL and opt IBM Elasticsearch. So just continuing on with the disk space consumption. When the cluster is running, it will generate logs and it will generate data and it will consume disk space. So these are some of the directories that you want to look at to make sure that you're not running out of space. The LSF work directory contains all of the job data. So as you're submitting jobs and they're completing, the data is being stored in this directory. You also have an LSF logs directory, and this is for the different processes that are running on the cluster, and they're dumping their logs there. You also have the Elasticsearch, well, not really a database, but it's storing its shards in this directory here, and they can get quite big, so you'll maybe need to take a look at that and make sure you don't run out of space. And finally, you have an HA shared directory that's going to contain the work directory from here and the conf directory. So if you are using that, well, you might want to make sure you don't run out of space. Okay, in terms of CPU and memory, well, it really depends on how many machines you have in the cluster and how many active jobs you have. So, for example, a small cluster with maybe only 1,000 active jobs, well, you only need like maybe a gigabyte of RAM, and pretty much any CPU will do the job. Whereas if you have a very large cluster with, say, over 1,000 hosts and 500,000 active jobs, you're going to look at having a minimum of 32 gigabytes and 8 cores. So, you just size the machine according to your anticipated load. Likewise, for the GUI host, you want to do the same thing. Here, though, the requirements are a bit higher because the GUI process is a bit heavier. So you're going to see that we're going to want a minimum of 96 gigabytes and 16 cores for the large cluster. Okay, let's talk about the software prerequisites. So what OSs are supported? If you're running on a PowerBox, this will work with RHEL 7.3 Little Endian and Ubuntu 16.04. If you happen to have access to a Power 9 box, you'll need to install RHEL 7.4 on that. For x86, we work with RHEL 7.x and CentOS 7.3. So we've tested CentOS 7.3, but other versions probably work anyway. If you want some Windows nodes in there, you can have those, but they can only have the LSF servers role. And the install process is going to be somewhat different from that. And that's actually covered in a separate video. If you've got some ARM boxes, well, they can be RHEL 7.4 or Ubuntu. In terms of prerequisite packages, if you're running RHEL or CentOS, we don't need any. If you're using Ubuntu, well, we're going to need the Ansible package and the RPM tools. So in terms of internet access, for RHEL or CentOS, we don't need any internet access. But for Ubuntu, we probably do in order to pull in those dependencies. Okay, so we want hostname resolution to be set up and more importantly be accurate. So that means that your DNS or host files have to be up to date and correct. So all hosts in the cluster need to be able to resolve the LSF masters as well as the deployer node. We also asked for a configured OS repository. So we do an RPM based installation, and we will want to pull in some OS dependencies. So we will need that OS repository to install those packages. We also ask for passwordless SSH, at least from the deployer node. We are using Ansible to perform the installation, so the deployer node has to be able to SSH to each node in the cluster and perform some of the installed steps. Oh, one other note, Ansible does support other options, so if you want to use those other options, you can do so, but we've tested with passwordless SSH. As part of the install, we do create a system account, and that's with the LSF admin user. And it's a system account so that it doesn't expire. And we create a consistent username and user ID across the entire cluster. If you are using or if you have created an LSF admin account in LDAP or RNS, that's fine. We can use that one as well. If you are using HA, we will need a shared directory that can be NFS or Spectrum Scale, and we'll use it to store the configuration and work directories. Optionally, you can have an external database for well, again, an HA configuration. Okay, let's talk about the network. So, in very simple terms, you can have a simple network where you have your corporate network and you plug your servers into that. The machines maybe only have a single NIC. That's fine. That all works. Again, it's all boils down to making sure that each node in the cluster can resolve both the master and deployer nodes. You may also have a more advanced network configuration like this, where you have perhaps multiple networks, so a low latency network, say for MPI or with InfiniBand, and you might have the LSF servers connected to that. Then you might have a private network for where all the workload gets submitted and flows through, and then maybe a corporate network where the users actually reside. One note there, in this configuration like this, for the GUI hosts, they have to be accessible on the corporate network, so you should use the name of the on the corporate network for those GUI hosts when you're building the configuration. And you'll see that in another video when we actually do the install. Okay, in summary, so you've seen that the machines in the LSF suite cluster can have different roles, and that those roles determine what function the machine will have within the cluster. You've also seen that a machine can have multiple roles in that cluster. We've also talked about some of the prerequisites, like the OS requirements, the memory, CPU, and disk requirements, and we've talked about the network configuration. In the next video, I'm going to provide an overview of the installer. And if you want more information, you can, of course, go here to this URL. So thank you very much. I hope you enjoyed that.